All right, we're going to get started now. Good afternoon, everyone, and welcome to the second OPWA National Public Works Week's Technology Showcase session. After having to cancel last year's event due to COVID, we're thrilled to be back, even if it's virtual, and hopefully next year we'll be back to an in-person event. First, before the presentations get started, I'd like to send a thank you out to our annual sponsors, who are listed on the screen now. The OPWA appreciates your continued support. Second, there's a few housekeeping items to go over for today. This is the second of 3 sessions this week. The first was yesterday afternoon, and the third will be held tomorrow at 2 p.m. As a reminder, all sessions are being recorded and will be available on the OPW website to view again. An email will be sent to all attendees that will allow them to vote for their favorite presentation and help determine the OPWA Technology Showcase Project of the Year. Polls will close at the end of the day on Thursday, with the winner being announced on Friday. If you have any questions during the presentation, please put them in the Q&A or chat box, and we'll have them addressed by the presenters at the end of each presentation. Okay, to get us underway, today's session is sponsored by Iris R&D Group. Iris is a privacy-centric smart cities hardware and data platform company offering an end-to-end data collection and data reporting solution to municipalities, resulting in work automation, cost efficiencies, and higher levels of service, helping municipalities make data-driven, evidence-based decisions and interventions. David from Iris Group is going to say a few words now. Go ahead, David.
Oh, thank you. If you can stop, hello everyone. If you could stop sharing your screen, I can share mine, and there we go. And we're good to go. Thank you again, everyone. It's a real pleasure for us to be with you now. Just going to spend the next few minutes, maximum 10, try to get through it quicker, just telling you a bit about Iris and our technology. As mentioned, we're a privacy-centric smart city. Our application has, our technology has application across multiple industries, but we're focused on smart cities. And we are an end-to-end data collection and data reporting solution. We provide legislative compliance, cost efficiencies, and higher levels of service with our technology. Some quick facts. We have privacy embedded in our technology completely. We're compliant with the MFIPA privacy laws. Our technology is patented. We have applications, like I said, across multiple industries. We've received strategic equity investment early on as a startup from Geotab, a global telematics company. We've partnered with Esri, a fantastic partnership there. And we've just recently successfully finished a financial raise with a total of $1.5 million received so far. To the issue at hand with regard to our smart city sector, data collection is very slow, it's expensive and prone to human error. This is a client before we arrived going around with clipboards looking for potholes and cracks and maintaining their roads according to minimum maintenance standards. The same cities are going around and contracting with companies like Food Grown Stantec, doing huge, very expensive road surveys. The challenge, though, is to get municipalities to embrace technology and move towards a more inexpensive approach and get away from the slow and infrequent data gathering that's prone to human error. And so our solution meets just that. It's an Iris Go data collector along with a data platform visualization tool called Iris City. And the Iris Go data collection device is forward-facing. There's no in-camera facing. There's no faces ever collected, and so no private information ever stored. And it's an install and forget device. We collect data in real time using AI. We can deploy in both a static and mobile placement. Our devices are waterproof. They're solar powered in some cases as well. We monitor 24/7, and we can collect a whole ton of data, which I'll show you in a moment. We started off looking for AI to look for potholes. And we quickly evolved to this, where we collect a bunch of data now on the fly. That's our device on the left on the City of Hamilton's garbage truck. And it's collecting roughness index there to provide PCI, pavement condition index data. We're collecting signs, other right-of-way assets like hydrants and trees and things like that, all in a privacy-centric basis. You can see cars and if there were people there being redacted, all in one pass. This is our garbage truck in Hamilton collecting data with regard to participation rates of blue box and green box bins. This is a sample of our redaction technology. You can see this is patented. It's patent pending. It's done on the edge on our device, so there's added security around privacy on that. The value proposition we provide, just a couple of examples here. MMS, minimum maintenance standards, for those potholes and crack identification and road inspection that's done daily. We can take out at least in some cases a lot more than 50% of the costs and effort in that. And in PCI road survey data, we can collect that at a substantially lower cost and effort basis as well, all leveraging the technology we've built. Iris City, like I said, is the data platform. It provides data points, GIS centric. We have the ability to look at fleet optimization and MMS as well as other data points. It's pretty flexible. It provides dashboards and things like this, which focuses on legislative compliance. So we can address issues the legal from a legal perspective with time stamping and other protections that can hold up in court. And this is an example of our dashboard that has the flexibility to look at the data by time frame, by municipality, by ward, and other sort of layers. Here's an example of a sign inventory that we're doing for a client. Speed signs and other signs our AI model is quite robust. We can train it quite quickly for any different and specific type of asset that may be of interest to a client. Again, that's another example of garbage participation dashboard that we have. And all this data can flow into our clients' downstream processes and enterprise-wide systems seamlessly with APIs and other things. A quote from Cyrus Tarani in the City of Hamilton. He's excited about the work we're doing. Some examples of data that we're collecting for them currently: illegal dumping, damaged signs, graffiti. And reports are always built, are continuously built, and it's just a click away. It avoids the complication of having to go through RFP processes for data that is readily there and available, and that seems to be working. And then I'll finish off just with a little time to spare, just a few recent awards that I'm excited to share with you that we've received. We're a top 20 finalists in the Infra Challenge. That's a global infrastructure hub. It's a G20 organization based out of Australia. And this Infra Challenge is an annual challenge. They receive hundreds of applications every year from 30 different countries. And so it's quite something to make the top 20. And Iris is the only Canadian company to be in the top 20, beating out competition from around the world. So pretty excited about that. We won an award with the City of Vaughan's Smart City Challenge. That was recent. And then finally, we're the award recipients of the Business Excellence Award put on by the Burlington Chamber of Commerce, which is coming up next month. So thank you. I guess I'll open it up to Q&As if that is part of the process. But thank you for your time.
All right, thank you very much, David. That's some great information on Iris. So Our first presentation this afternoon is on the waste DriveCam technology used by the City of Hamilton that David mentioned. The daily delivery of curbside waste collection services includes many risks and unknowns. In this presentation, the City of Hamilton Waste Collections Group will discuss how they're continuously leveraging drive camera technology and the step towards AI features to continuously improve safety and service delivery. Our presenters are Anthony Ventura, a superintendent of operations with the city who has over 20 years of experience in managing both public and private waste management systems, and Glenn Watt, a project manager with the City Waste Collections Department who has 16 years of experience and plays a key role in maintaining Hamilton's waste management system. Take it away, gentlemen.
Perfect. Thank you very much. Hopefully everybody can see me here. Hi, my name is Anthony Ventura, and I'm going to start doing a presentation today regarding, I'm happy to share our story about how technology, more in particular dash cams, improve the safety and data collection of our crews. So just bear with me here. Is everybody good there? Can we see the PowerPoint presentation?
Yes, Anthony.
Perfect. Okay. So I'd like to start out again that we started using
presentation mode
back in 2015. Reason being is that, in waste connections and waste collections is referenced as the top 5 most dangerous occupation in North America. With that being said, waste collections has one of the most highest incident rates compared to other service sectors. So as you can see in some pictures here of photographs and stuff, we face incidents every day, which include obstacles in our path, which can be both forward or reverse motion, hazardous road conditions, and most often the other drivers and challenges presented on the road. The next slide is our risk pyramid. Some of the risks that we have focused on in operation can definitely be contributed to poor driving habits. And these poor driving habits lead to risky behaviors on the road, which of course can turn around and cause collisions, injuries, and possibly fatalities. As you can see in the risk pyramid, a collision doesn't usually occur without several close calls or near misses first. So when I look at this chart, I say to myself, it's not a matter of if, but a matter of when. So we started thinking, what do we need to do to fix this problem? What do we need to do to have a plan implemented? Well, it all started with a commitment and focus from all levels to implement the programs, the training, the coaching involved, and of course the enforcement to help prevent these poor driving habits and behaviors from continuing or forming. So DriveCam by Lytics. So this is a video event recorder. So like I originally said, in 2015, we piloted a project in waste collections using the dash cams in 10 vehicles. Due to the pilot success, we expanded it to our entire waste collections fleet in 2016. We currently have 40 units in service. So the DriveCam program currently has more than 1.3 million drivers protected worldwide. As a client, the clients, they see 625,000 fewer instances of risky driving. And there's over 120 billion miles of professionally analyzed driving data. Lytics also has over 450,000 units installed in over 500 fleets across North America in the various service industries. This operates through a video event recorder located in the front of the windshield. This is an actual model of what we currently have. There's a dual lens. There's a forward lens projecting out and an interior lens facing inside. So the video event recorder has the dual lens, which constantly runs, but it only captures 12 seconds of video and audio when triggered by an event, An event could be a hard brake, a sudden turn, a hard turn, swerving, sudden acceleration, or even like uneven ground surfaces. So a video clip will show 8 seconds prior to the event and 4 seconds after the event. This may seem like a lot of footage, but typically only 5 minutes of video is recorded per month. And good drivers often don't even trigger any events for many days. This device can also be manually activated by the driver to record any other type of event, such as an interaction with a customer. So this feature has been particularly helpful to capture the facts if an incident has occurred. We also encourage our operators, if there's an issue at a location, not regular compliant, irate customer, wrong setup, activate the camera. So it can help us address the issue later in helping resolve the complaint. Another outside factor is just this last summer, we had a crew driving down the street when a car came out of a townhouse complex without stopping. It actually ended up coming through and T-boning another car, and it actually rolled over. Our driver, who was witnesses, had the presence of mind to trigger that camera. So the event was actually captured. Well, the crews went out, stopped and assisted the injury and advised police we have the camera. I'm not sure if the police used this as evidence, but it was submitted and they did ask for it, and we were able to provide a copy for that. So it's on a good news story. The inside view. So here what happens is, this is exactly what happens. Normally a video normally plays here, but what happens is the video is constantly looking at the interior of the cab, more in particular the driver, the motion, everything that's coming around you. And then of course, this is all facts that come into helping out resolve what the issue actually was. This is the outside view. In this particular example, we're looking at a driver who's approximately driving at 39 miles per hour. What happens in this video is that he actually continues and ends up hitting that curb right in front of you, drives right over it. Well, the video inside the cab as well as the exterior helped us determine the deciding factor on whether it was distracted driving, something was going on in the cab, or if there was something that happened on the outside.
Hey, excuse me, Anthony, if you go into presentation mode, that video will play.
Sorry, Glenn. Hold up there. So just in order to show you, so what happened here is that the driver actually then failed to report it to a supervisor immediate, failed to contact maintenance to say, hey, that the truck went over a curb, forgot to write everything down on his driver's sheet. Regrettably, this was a high-risk employee that we found through DriveCam, and over time, we kept on continuing to coach on the same events. We seen that the coaching wasn't working and we needed to move towards a progressive discipline. So needless to say, the operator no longer works for the city of Hamilton. Sorry guys, I'm just gonna go back to that slide we're at just so I can show the videos coming up next. This was the video where the city of Hamilton employee is no longer with us. This would be the same employee. Different truck, different day. So obviously the view on inside the cab is really what helped us initiate all the evidence taken and where we needed to go through discipline. This one I'm happy to say is based on our drivers. So if we watch this video here and then I'll comment on it. So that's right, you did see the truck flip. So both of these operators have allowed us to use this video as a teaching tool for others. Neither of these operators received any long-term injuries as a result of this crash. So we use this video as evidence during the Ministry of Labor investigation. And as the result of the video, the ministry determined the operator was not reckless and therefore did not lay any charges. The follow-up video after this clip also shows us that neither operator lost consciousness during the incident, which is another level of paperwork and injury to deal with. But I can tell you one thing: when I responded to this accident immediately after, the first thing the passenger said to me when I made contact after the accident was, "Thank you for making me wear my seatbelt." We use this video as staff meetings often, and we remind staff of the importance of wearing seatbelts. There have been no questions ever since. So the results. There's improved driver performance. We address risk management. We optimize productivity and effective use of resources. So DriveCam program offers several benefits. That driver training component, that video footage, helps us assist with instructing and coaching employees on proper driving techniques. Claims management, that audio and video recordings provide an objective account for what happened during an event. And again, for customer service, where videos can record details with surrounding areas to assist with customers and service issues. As a result, we have 72% decrease in frequency, a 74% decrease in severity of risks. Our drivers with the highest score have improved their performance by 90%, 62% decrease in driver distractions, and a 21% reduction in traffic violations. Another stat that we don't have on a slide, which is just equally important to share, would be the number of accidents that we've now gathered data for of preventable collisions and accidents. So in 2016, when we first started, we had 25 preventable accidents. In 2017, we went to 24. In 2018, we went to 14. In 2019, we went to 10. In 2020, we went back up to 15. And for 2020 year to date, we only have 2. So obviously the proof is in the pudding, where we can see that we are trying to definitely play a role for our crews, our drivers, and helping giving them the tools to prevent themselves from collision. Another interesting stat is our contribution to CVOR points, waste to our overall score. So in 2016, we were contributing 18 points. In 2017, we were contributing 28 points. In 2018, 25. And then in 2019, we started seeing the proof of the pudding of what we're doing. Only 2 contributed points to CVOR. In 2020, we've had only 4 points. And in 2021, we have 0 points so far contributing to the CVOR. And just in waste, our waste collection vehicles travel over 1.5 million kilometers per year. So the road ahead, what does it look like? We still focus on the top 3 risk behaviors associated with near collisions. We're continually developing campaign for prevalent behaviors. We continue to provide driver coaching within a 4-day period, so it stays really fresh and it's still in our minds. There's positive reinforcement through driver recognition programs, and the expand the use for DriveCam technology. So to further complement this technology, we also implemented two driving systems. One, Smith driving system, which focuses on techniques to prevent collisions. So this helps drivers to see, think, and act their way through a multitude of driving environments, challenges, and changes that exist wherever drivers travel in whatever types of vehicles. DriveWise, same scenario, helps you with the eye lead time movement, eye movement, being proactive, being predictable, and creating a space cushion around the vehicle. Both programs, we give our drivers the ability and the techniques to create more space around the vehicle, more visibility to eliminate surprises, and more time to make thoughtful decisions. Next, I'd like to pass it over to my colleague, Glenn Watt, who is Senior Project Manager, Waste Collections. Go ahead, Glenn.
Thank you very much, Anthony. Yes, my name is Glenn Watt. I'm a project manager in the Waste Collections Group. And I'm very excited to talk about a project that we've been working on since April 2020. I've had the pleasure to work on a project that builds on the success and the acceptance of the Lytx dash camera safety program, as well as supports diverting waste from landfill through greater understanding of our waste programs. Our group has had been fortunate to partner with IRIS Research and Development to test the potential of an automated data capturing and reporting system, the IRIS Go device that David spoke about. The partnership was brought forward as an avenue to support the Ontario Smart Cities Challenge, the challenge to empower communities to adopt smart cities approach to improve the lives of the residents through innovation, data, and connected technology. A trial is now ongoing to collect data on assets on a daily basis during the regular waste collection schedule, essentially inspecting city assets in the field on a consistent weekly schedule as waste collection vehicles pass by on its route. The cameras are currently installed in 5 specific waste collection trucks. This is in addition to the Lytx devices that Anthony spoke about that are already installed in all the waste collection vehicles. In the image you see the device being held on the left and also installed on the left-hand corner in the windshield of the truck. Next slide. The collected data can then be accessed through the IRIS City dashboard platform for use in reporting, asset locating, and monitoring. This can support cost efficiencies and work automation and better levels of service, helping municipalities make evidence-based decisions. For the waste collections group, we are developing specifically the system to gain insight on verifying the GPS locations and conditions of assets in the field, such as our public space litter containers, blue boxes, and carts. This supports our group's efforts for managing municipal assets. Also supporting our clean and green strategy by inventorying locations where roadside litter and graffiti is detected. In this image, you can see the locations of the public space litter containers that our group services. Prior to this trial, we did not have GPS locations for our litter bins. Next slide. In this image, you see the participation dashboard in development. This gives insight into our set-out rates to better understand waste diversion programs and participation levels, such as how many people are using the blue box, the green cart, and other waste programs. This can allow us to plan strategies to increase participation in low-performing areas. Waste participation studies are historically conducted manually on foot by numerous waste staff over a 4-week period that can be resource-heavy and time-consuming and leaves room for human error. For example, when the waste collection truck picks up the material before the audit staff collects the data. Because of this, the studies are not conducted as frequently as they should be. The IRIS Go technology could replace the need for staff to physically walk the streets collecting data. This technology essentially will be providing weekly participation rates all year long. Several tests have been conducted to verify the accuracy levels with good success in the ideal conditions that have no obstructions such as cars or snow, etc. As a next step, we are currently developing a plan to repeat a past Stewardship Ontario participation study using conventional means, clipboard and pen, and also allow the IRIS system to complete the inventory. The results will be used to determine the level of accuracy of the system for waste set out and participation purposes, as well as our next steps in deploying additional cameras. And really, we are just starting to scratch the surface to this Really, we're just starting to scratch the surface to the amount of applications this technology can be used for in waste management, as well as other city services. Next slide. And here's an example of the participation dashboard. As you can see, the levels of green carts, garbage bags, and blue boxes. Next slide. So on behalf of Anthony and myself, I'd just like to thank you for the opportunity to speak about Hamilton's use of the dash camera technology for operational safety and data collection within the waste collections group. Thank you.
Well, thanks very much, Anthony and Glenn. That was great information. James, do we have any questions from the audience on this?
Actually, yeah. What was the largest challenge in implementing either or both of these programs?
If I could set in, one was the overall commitment from all levels and the enforcement aspect, dealing with the unions in particular in the beginning stages on what was acceptable and not acceptable. And and the union saw that our commitment to safety was paramount. And you've seen them starting to buy in. I think that was our proudest moment, is when the unions has started to accept this.
Great. Thank you very much.
The only thing I can add to that one is, like Anthony said, is with getting over the hurdles of having the lytics system and working through all the and demonstrating all the benefits, it was the staff are almost expecting different types of technology to be installed in a constant continuous improvement atmosphere of the collection vehicles. So if there was nothing being added, they'd be almost at the point where they'd be asking why.
Just one other question that just came in. Were there any privacy concerns with respect to the cameras? And I think you might have touched on it a little bit, Anthony, with unions.
Yeah, so the privacy definitely was an issue. And the format that we have is that we don't have a continually recording on the inside. It is only event-based at the current time. So if there is an event that gives us causable, it's causable for us to go and investigate and see what happened. And then the use of the camera can be determined if it does point in that direction or not. So it is a relationship that we built over the years with the union and come to that understanding.
Great.
But yeah, the way we got around it is that there wasn't a continual recording on the in-cab portion only.
Great. Thank you very much.
All right. Thanks again, guys. So that'll lead us to our second presentation this afternoon, which is on the Des Moines area MPO bike data project. Communities around the world are striving to make a positive impact on the environment by encouraging the use of pedestrian infrastructure, such as trails and bike paths. This presentation will explore the innovative methods being used to improve condition monitoring, plan for maintenance, and stretch budgets related to the active transportation infrastructure. Our presenter is Rob Huber, a co-founder of Rival Solutions, Inc., which is focused on evolving business intelligence for professionals through the consolidation of mobile consumer technologies, cloud computing capabilities, and web visualization tools. Go ahead, Rob.
Okay. Thank you, Bill, for that. I have to talk with our marketing person and maybe change the wording on that to be a little more simple, but you know, lots of fancy words, right? Thanks to OPA for giving us a chance here to present today. I think this session this afternoon is where I'll be touching on the same kind of concepts here with you know, essentially what I think is you know, bringing lower cost technology to still get a lot of value out of a data driven decision process. So I think this fits quite well. There's going to be some overlaps here of what you've heard already. But today we're going to talk about what I'm going to talk about, and I'm excited to talk about, is an ongoing project with Des Moines. I know this isn't in Ontario, but our company is located in Ontario, so they've reached out to us in 2018 to help solve a problem they had with their active transportation network. So I'm going to share this project, the success of this project. It's really a practical implementation of how you can use low-cost technology, basically to support, you know, the overall goal of managing a active transportation network. So just quickly, a little bit about the area we're talking about. So Des Moines, looking in Iowa. They have about 600 miles of trails and growing, connecting a bunch of smaller urban centers together. The whole area is about a population of about 700,000 people. So lots of people getting out and trying to get active. But as we move to this next chart here, you see here, sorry, wrong button. It's quite spread out. So this is just a quick look at what they're dealing with, and the red lines being their current trail network. So they have all these different pockets of little towns out around the main metropolitan area of Des Moines. And people from all these different little outshoots here do like to bike into Des Moines for the day and bike out and enjoy, getting out on the trails and not using cars. So a big challenge for for the metropolitan area, because trails are not a high value asset. Not a lot of budget, not a lot of resources available to maintain a network like this. What's interesting though, when you're talking about moving people around and moving wheelchairs around and moving anything that's not a vehicle, safety is the number one concern, and they want to make sure these trails are safe for walking, safe for people on bikes that are traveling at high speeds. So a little bit of a different challenge than, let's say, traditional assets like roads and bridges, but same concepts. So back in 2018, they did have this challenge where their existing network was evolving. They were adding more length to their overall network. They were starting to connect these little centers all together. And as that happened, the money that was taken away from, let's say, the existing networks showed that they were starting to mature, and that's just a nice way of saying they were starting to fail. So they had to come up with a way to prioritize their spending, as we all know on this call, can be a difficult thing sometimes. They had no information available to make any sort of data-driven decisions. We've been talking about that a lot today. And there was no effective program in place. There was no standards in place to be able to do this. They wanted to achieve this on an annual basis. They wanted to stay on top of it and get more proactive. And they did research a little bit on their existing asset programs, let's say their roads program. But it was obvious at the beginning that trails are a different animal than roads. So they ignored some of the existing, I guess, programs they had in place for doing pavement inspections. You saw a picture of those two data collection vans earlier. Some think you can just drive one of those down a trail. Probably not the safest thing to do. So they ignored that, and they started with a blank slate. And this was the solution they came up with, and we're going to talk about this over the next, next 15 minutes. They put together a Databike. So they went out and contacted a few different firms to help them assemble this. And essentially, it's an electric bike that's mounted with a few different sensors on it. We have a 360 camera that's mounted at the top. There's an iPhone, in this case, an iPhone mounted on a rigid platform here that's used as a sensor to collect data, as well as to communicate data to the servers where it's going to be processed, as well as an interface to operate all the sensors. And then they had an additional camera at the back to really focus on the condition of the trails. And then they branded it up because they were very keen on making sure that public were aware of what they were doing. Surrounding municipalities were very keen on what they're doing, and they really wanted to promote this more to drive their goal to make their community more healthy, more active, and join the different centers together. We all know the benefits of being active and active transportation networks and what they can do. So obviously they have an impact on the environmental side of it. So the nicer you make your networks or your trail networks, the nicer it is to get out there and promote the need for people to come out. The less cars are on the roads. It's obviously great for health, and on an economic side, if you put together a proper plan and a proper network, you can drive people to some of your more urban centers to help support businesses and bring people in that way. So a lot of different benefits outside of the obvious, I think, and this is what was driving them to put this program in place. They did need a turnkey solution. So while they were looking for different pieces and different parts, they were looking for everything from getting set up and defining the network and getting the data collected, to reporting this out and making decisions on, you know, a capital plan on how and where to spend their dollars on what parts of the trails. So they were looking for an entire solution. At the beginning of the project, there's a lot of discussion on what to do on trails, and the one key thing that was discussed was they wanted to have a really high value project, but they wanted to make sure it was simple, so it was easy to repeat annually. So when looking at some of the KPIs, you know, we talk about roads, and a lot of us are familiar with road KPIs. There's a lot of different things that come with trails. So aside from the basic list of condition defects, surface related defects, things that the user will see on the trail itself, on the structure itself, there are a lot of other things related on the safety side, such as, you know, the presence of markings, any sort of critical distress that might cause your tire to catch and throw you off a bike, lighting for when you're traversing the trails at night, geometrics, as well as line of sight. There was a project done in the city of Montreal, and they have a big problem with trails coming around a corner, and there being a building right in the way, and they have multiple cases a year of just two bikes crashing into each other. And then signage. So similar things to roads, but just on a little bit of a different scale. And then the accessibility, how you get to these trails, where you park, are there obstructions, are there gates? Can you get through the gates if you're in a wheelchair? Little things like that are very important to the community that don't use cars and would rather be on foot. And then as well, you know, using historical trends and data to do prediction, you know, historical maintenance records to see what has worked in the past for keeping trails performing over a longer period of time, and also integrating future master plans on how that trail network's going to evolve. So these are all the things that were considered in terms of an overall trail performance and management system. I will say there was some talk, and they did look at, you know, can you shoehorn something like this into, let's say, a pavement management system, and use the concepts there. A lot of the times that is what you're doing, is shoehorning, but it was quickly determined that there was a lot of things missing from some of that road centric stuff that couldn't be applied to trails. So again, they decided to steer away from that. So the main objective was to be able to quickly go out and get data, and collect automatically accurate and repeatable trail performance annually. And this was driving their funding priorities annually. A little bit of a challenge that they had was that it's not a central funding pool. So because of all these different local offshoots to the metropolitan area, the funding came from many different sources. So they had to have a very objective way of saying, here's the amount of budget you're putting in for this improvement to benefit the entire network. And what they're ultimately trying to get, as we've been talking about here today, is a level of service that can be repeatable and maintainable over time. So the data collection itself is where they started. So they were using a Yuba Spicy Curry electric assist bike. Sorry, the spelling mistake there. That's quite the name for a bike, but it was an electric assist. And we'll talk about how they actually crowdsourced this approach later. I'm going to talk about that at the end. But it didn't require people to go out there and pedal in 100-degree temperatures for hours. It was assisted. And then the sensors on board. Again, this one, the iPhone was used to as a sensor. So the accelerometers inside of it were recorded at 100 hertz. Images were collected every 10 meters, and a 360 kind of streetscape camera was collected as well every 10 meters. And all these combined were used to basically, you know, achieve that goal of a single KPI to be able to use for budgeting their rehabilitation and their maintenance. So to achieve the data reliability and to make sure year to year that if you say your KPI 1 year is a average of a 7 out of 10, you want to make sure next year that same KPI is relative to that. Without standards in the industry, you have to revert to technology to be able to show that you can be repeatable over the years. A lot of times you hear the word PCI. It can mean one thing to one person. It can mean something to somebody else. So making sure it's repeatable over the years was very important. So behind the scenes in this whole process, there was a whole set of technologies used, and I'm not going to dive into the details on this. But really, this is based on, they're wrapped with a whole rule-based processing approach where we worked with the project manager, and they gave us what their goals were for the project and what they're trying to achieve, and then specific rules and specific algorithms were put on top of all the technology to make sure that reliability was put in place. So you've heard these buzzwords probably many times now over the years. It's the direction that infrastructure inspection is going. So the combination of deep learning, combination of computer vision, which is essentially looking at an image and detecting something from an image, and then coupling that with GIS, all of that combined produce the results that they're getting on an annual basis. But one of the things that was quickly identified was that, even though automation's great, I'm a firm believer in it, it's never going to be 100%, and it's never going to be 100% complete. There's too many variables at this time in terms of the environment when you're outside and what you're collecting. So there was a need to have a dashboard for them to visualize the results and also be able to validate the results and make any changes based on that data that came in. So everything was loaded up into to a dashboard automatically and hosted, and then they can log in and they can see the results, see the images, and they can make any changes to either the learning database that's used to train the AI, or just to make changes to the results that that'll come in automatically. So that's just an example here of the dashboard that they use. And then the other thing that they're able to accomplish was that they did decide that they wanted to do additional inspections. Maybe they wanted to start, logging mailboxes, or not mailboxes, park benches, or garbage cans, or anything else maybe down the road. There's the ability to supplement the image, the automated data that came in, and add that to the overall database. So after all that's accomplished, and after they had the bike set up and they were able to go out and get that information, and it gets reported, against their GIS map, the next step is really to make the decisions on what's the plan for the next few years in terms of how we're going to spend the money. So they didn't just want to stop at an overall PCI, or what they're calling a TRCI, which is Trail Condition Index. That's this block here of a basic asset management process. They wanted to go another step, and they really wanted to automate the entire process to say, okay, how do we get down to getting a dynamic plan that keeps coming out of the system, that evolves and keeps saying, here's the priorities of where you're going to get. And this each year is ongoing. It keeps being manipulated based on the different external data that comes in. So things like their master plans come in, and they have to account for that in the overall decision process. Things like the trails being added have to be included, or planning to be added. Those all have to be considered when you're trying to put everything into a bucket and say, okay, where should I spend my dollar? What area of the trail? And what's the best bang for my buck, basically. So this was the I think we've probably all seen this. This is the base, a basic asset management process. and this was fully customized for trails. So things in the decision process may not be just around what defect is being seen on the ground. It might be things like, can you actually get into the trail with a wheelchair? You know, and if you can't, well, you might have to get a crew out there. You might have to get a work order out there to actually improve that while you're doing the trail improvement. So different aspects of accessibility, the parking areas and things like that are all included in an overall trail management program. So some of the outputs, I think, but by now there's enough dashboards out there. These are pretty standard. So you know, the results that they got was they did have a well-defined network where they have a very manageable and set of overall trail names that they had. This list isn't 700 records here that you're trying to decide between that. They were able to get it down to something that's quite manageable for that 600 miles. And this is the reports that keep coming out, and these are the reports that update every time they go out and get the data. And then with any dashboard, they're able to drill in, and they're able to get the details out and see what's going on exactly on that trail specifically. So a little bit about the deployment. One of the things I mentioned at the start was that they did have a challenge with just not having resources to go out and collect the data. They did not want to outsource the data collection. They really wanted this to be an in-source project, and they wanted to promote this and promote innovative ways to manage the network. So they actually crowdsourced the use of the Databike. They built 2 of them, and then they offered their staff, and they actually offered even the community to come in and take the bike out for a ride during the day. And they had great success with it. So they did a whole Facebook campaign, and people were lining up to come grab the bike and go bike around the municipality for a day and then return it. There's nothing special you have to do on the bike to operate it. It's basically get on the bike and go. Make sure you have some water, and you hit one button and go bike around and get the data. So I felt that was quite an innovative way, similar to the example of installing the iris camera on the garbage trucks. It's ways to leverage existing operations or existing ways to go out and get data more often. You make better decisions when you get data collected more often. So another creative way that was accomplished. So finally here, how it turned out. So they've been ongoing here since 2018. The latest report that came out was in 2019. If you want, you can easily search for this title here, Central Iowa Trail Condition. It's publicly available. It has all the metrics in there about how the data has been used to manage the network. But they achieved their goal, so they're able to now understand the current conditions and define a level of service. And what they need to meet to make sure that the public are happy with the condition of the trails. They did put in a performance-based and data-driven program, and I use the word program, not project, because program implies that you're doing this ongoing and you're doing it annually, and you're keeping up with the data that the system needs to output the results. They got the community involved to reduce any of the internal resourcing burdens they may have. And then there's several different value add things that came out. So the images that were collected, the 360 camera street view type image was used on their website. So faces were blurred on it, and then they actually made those public to showcase some of the nicer areas of their trails. To help increase their tourism and have people, come in from even, maybe an hour, 2 hours away just to ride the trail network they have, because it's quite a nice area they have there. And then since then, I just wanted to quickly show that, there's been a lot of, since they made this publicly available and they did a lot of job with branding this Databike, it really has taken off, and there's been a significant amount of interest in projects that have been inspired by this, maybe changing their process a little bit here and there, but in general, a lot throughout Canada here in the US. These are some more recent ones that have been done. There's been even discussions with some of the larger networks in the UK to again use this type of concept to get data so they can make decisions much quicker. And with that, I will take some questions if there are any.
Great, thanks very much, Rob. Great presentation. James, do we have any questions from the audience for Rob?
Yeah, just one. What was the time frame from inception to actually being out there and getting usable data? What was the approximate time frame of that?
Oh, it was quite quick. I guess the nice thing about the hardware is that it's all off the shelf hardware that's available. The longest part of it, I from what I remember, was the bike being assembled itself, like built with the mounts on it. But theoretically, all you need is a phone and a mount, and yeah, you can be up and running immediately. So I don't remember the exact length, but I'm going to say weeks, not even a couple weeks before we had data coming in and being processed and reported up on the dashboard.
Oh, that's great. Thank you very much.
All right, well, if that's the only question, that'll be it for today's section. Just wanted to say thanks again to our sponsors, presenters, and everyone who took the time to attend the presentations today. Don't forget to join us tomorrow for the third session, including AI for road conditions in Guelph and mobile cloud-based technology for design and construction in Durham region. And of course, don't forget to vote for your favorite presentation on the OPWA website. Enjoy the rest of your day, everyone.